Let's look at what we can do with these trigonometric functions, sine graph and cos graph. And we've seen before that we can do transformations. And if you just think back, say, if we look at y equals x squared, and you know that y equals x squared just looks like that. Now, if we wanted to move that graph to the right, even though it's going that way, we actually subtract. So if we want y equals x minus 1 squared, that will move it to the right 1 unit. So that graph now will look like, will be moved over 1. So that may be y equals x squared. This is y equals x minus 1 squared. If we want to move y equals x squared 2 units to the left, we actually add 2. So that's y equals x plus 2 all squared. So it's got to go inside the bracket there. So we have moved the y equals x squared horizontally, and we do that by adding or subtracting. Well, it should come as no surprise that y equals cos of x minus, well, let's go x plus 90. What does that look like? So we're working in degrees. We firstly start with a cos graph. Let's see if we can stay on the lines. So our cos graph, as you know, goes from +1 to -1. Now, when we're actually drawing, and you're going to get a lot of opportunities to sketch sine and cos graphs, it's a good idea. The key points, there should be 4 gaps over here. We know that one complete period of cos goes from 0 to 360. So just mark off 1, 2, 3, 4. And this will be 360. So this is one complete period. Half of that will be 180. Half of that is 90. And that is the single unit. So that's 90, 180. So that must be 270. So that's a standard way of drawing. So go from here and mark out there one period, halve it. So no matter what this is, we're going to change the period a little bit later. So you're going to have to adjust things. It's not always going to be 360. So from there, one complete period, halve it, and then halve that again. And that gives you your 4 points for cos. And you know that cos starts up here, goes through there, down the bottom, comes back up, and goes up, back up to 1. Okay, so that's a standard procedure. Now, what we'll do is we'll actually use different colours, and we'll do the cos graph first. Before we do this, we'll just do the cos graph. So it just comes down, goes back up, and then goes over there. Okay, so that's one complete period of y equals cos x. Now, we've already seen from our work over here with quadratics and that with horizontal shift, that if you add something, you actually move it to the left. So every point here, we're going to move 90 degrees to the left. Every point's got to move 90 degrees left. So this point here, so if we had negative 90, so this point here will move across to there. This point here will move across to there. This point here moves 90 degrees there. This point here moves across to there. And that point there moves across to there. Now we should do this one here as well. Where would that go? That would actually come back down and be down there at 90 degrees plus that, which would be 450. So down there, the graph would be back down there at 450, so that's got to move back to there. And then we can connect all those. It's all dot to dot. And that is the graph of y equals cos of x plus 90. Okay, so phase shift is fairly straightforward as long as you just do it in steps. Start with a normal cos graph first, and then if you are adding some degrees, you are going to move it to the left. So positive to the left, negative to the right. Here we have a positive, so we're going to move the graph to the left. So every point on the graph, we've only just done the major ones, but every point has been moved 90 degrees to the left. So this is called phase shift. You're changing the phase. It is also called horizontal shift, but with trigonometric functions it's standard to use the term phase shift.